Good evening, everybody. So the very the vaguely mysterious music that we have come to know and love that introduces the broadcasts of National Astronomy Week finishes, and we are here on our fifth broadcast, more than halfway through National Astronomy Week. And thank you very much for those of you who have joined. I am David Arditi. I'm the Vice President of the British Astronomical Association. The National Astronomy Week is a collaboration of lots of astronomy societies up and down the country, as well as the BAA, the Society for Popular Astronomy, and Federation of Astronomical Societies, Royal Astronomical Society, and all the local societies. And we have recruited observers from up and down the country to try and bring you some live images of the sky tonight. But don't forget, one of the really the main feature of National Astronomy Week is the local events where people gather in fields or in car parks, and the general public is invited to look through telescopes and binoculars by members of local astronomical societies. And there are lots of those events up and down the country. For example, my local society in West London, the West of London Astronomical Society, or WALAS, is holding public observing, if the weather cooperates, in Ruislip Lido, on Friday, Saturday and Sunday from 6 to 8 p.m. And there are many other local societies doing similar things up and down the country, and they're all listed. And there's a map on the National Astronomy Week website showing the locations and all the details of those events, which you can go and see. And in general, they're all free, and the astronomers will be delighted to show you what they can see, if they can see anything, given the weather. And the weather is somewhat the point at the moment, because it's completely cloudy here in London, though I am optimistically at my observatory now. I'm in my warm room just next door to my observatory, and I've got the telescope out and it's pointing at Jupiter currently, but nothing can be seen. So let's review what is in the sky tonight. So here's a map of the sky just at the moment, and the yellow line is the ecliptic, the line on which all the planets move, and all the planets are there, which is why we're holding this event now. It's such a good time for observing planets. All the planets plus the moon. Uh, Saturn has actually set now, but Saturn was just set in the west just earlier. It was near Neptune. Neptune is now too low to be seen, but Venus would still be a spectacular object if it wasn't hidden by the clouds. And then high up, we've got the moon, which is now 8 days old, just slightly past first quarter, and many interesting features on the terminator, which I should think we will be able to view shortly with any luck. Then going further around, we've got the dimmer planet Uranus on the fringes of naked eye visibility, and then some interesting deep sky objects, the Pleiades star cluster. This is the Pleiades just there, and the Hyades cluster, Aldebaran bright red star, and nearby all that we've got the brilliant planet Jupiter dominating the night sky, and I hope we will be able to view that later on. And then coming round in the southeast, getting high up towards midnight, we have the red planet Mars, very similar brightness to Jupiter, but significantly different color. Through a telescope, much smaller, much harder to see detail on because although Mars is a lot closer than Jupiter, it's a much smaller object. And then you've got all the spectacular constellations of winter as well in there. You've got Orion, with the famous variable star, Betelgeuse's famous red giant star, the belt of Orion here, the sword of Orion with all the nebulosity, birthplace of stars, Rigel, another brilliant star, then the brightest star in the sky down there, Sirius. So really a wealth of things, and Mars is up in Gemini. We've got an interesting cluster, Messier 35 in Gemini, an open cluster, which we may get on to looking at later. And then Capella, very high up near the zenith, near the overhead point, and that's in the constellation of Auriga. And there's several very good open clusters in Capella as well, Messier 36, 37, and 38. And next door to that, to Auriga, we've got this constellation, Perseus, the hero, another famous variable star, Algol, this star here, which is an eclipsing binary, which is you can follow the variation of brightness of that with the naked eye. And up here we've got the double cluster, another famous cluster. So this area of the sky is full of interesting objects, which we will talk about more later. So that's the general overview of the sky. But really, the most spectacular object, if you've never seen it before through a telescope, is the moon. And the moon is constantly changing. As the phases change, we get different perspective on the craters as the shadows move across them. And we have a couple of observers who've got their telescopes on the moon. We have Dave Eagle, who is in the English Midlands, and he has a 120mm refractor with a camera on it, and he should be able to broadcast his images of the moon if all goes well. So let's go over to Dave Eagle and see what he's got.
Thank you, David. Yes, I've got the moon in my camera at the moment, so I'll just share that with you. So there you go. You can see this is the northern part of the moon here. So we can see two parts of the moon. Even with the naked eye, you can see the differences in the areas on the moon. There's the brighter highlands, which are heavily impacted, where they've got lots and lots of craters, and you've got the smoother areas, which are much darker. And these are what we call the maria, or the seas and oceans on the moon, because they used to think they had water on them, but they now know they're impact areas where liquid basalt has flooded into them and made these flat areas. And if we look here, you can see on the northern part of the moon here, you've got a heavily cratered area, which is quite bright. And as we come down, you can see this much flatter area is darker here. Now, what I'm going to do, I'm going to come down so that we can see some of the craters. Okay, let's a little bit too far. Let's go back again. There we go. So this crater here, this is a crater called Plato. And you can see some very nice shadows here because as the sun's rising, so this is the area that we call the terminator, and that's where the sun is rising. And then once it goes past full, it appears on the other side of the moon, and that's where the sun is setting. And we call this the terminator. And when features are on that terminator, the sun is coming in at an angle. It creates lots of shadows, so the features look much more pronounced towards when they're close to the terminator. You see those lovely shadows in Plato here. Next to it, you've got what looks like someone's taken a chisel and cut a valley through the mountains there, and that's the Alpine, what they call it, Alpine Valley. And you've got this very large flat area here called Mare Imbrium, and you see lots of little mountains poking up through the basalt here, and some lovely craters in there as well. We're going to continue our journey down the moon, past some of these lovely craters here. And we see a lovely mountain range coming into view. This is the Apennine Mountains up on the surface. And just here is a place called Hadley, and that's where one of the Apollo missions landed at Hadley Real. And this lovely string of mountains bring us down to this crater here. You can see most of it's in shadow on one side, and that's Eratosthenes. I think I've pronounced that correctly. So let's carry on down the moon, along the terminator where the features are much easier to see. Move that across a bit.
One thing people who haven't got a telescope might be surprised at is that you've got this slight shimmering all the time. The moon is never still. It's slightly in motion, and that's movement due to our Earth's atmosphere. So tonight we've got pretty clear view because there's not too much movement in our Earth's atmosphere. The movement is due to different layers of hot and cold air mixing up and changing the refractive properties of the atmosphere. And that's a thing which astronomers refer to as seeing, and we're always looking for nights of good seeing. And Dave has pretty good seeing there, and we've got a nice sharp view of the moon.
It helps because the moon is fairly high up at the moment, and so when it's high up, you're looking through a lot less atmosphere. When it's low down, you're looking through a much thicker part of the atmosphere, so there's more atmosphere to distort and bend the light, which causes these disturbances. Okay, so these were craters that were near the edge a day or so ago. Ptolemaeus, I believe that is. And if we come down here, you can see what looks like a straight line. A little bit. Here, this is what's known as the straight wall. It's not really a wall. It does look quite sharp, but it's actually quite a shallow angle. It's not as steep as it might look there with that sharp shadow, but it is a difference in layers between the two sides of it, and that's a really nice feature to look out for.
It's like a fault, isn't it? It's a place
yes, where the lava has cracked and one side of it has gone up slightly and the other's gone down. And if you look, if we go back up actually, go back up to the Mare Imbrium, you should see that there's these wrinkles in the surface as well, and they show up quite nicely up in the Mare Imbrium. Over here a second. If you look here on the smooth part here, you've got this darker feature which it sort of wiggles around like a big snake across the surface, and that's where the crust is sort of wrinkled up into these ridges. And there's another one here.
Any chance of increasing the brightness of the image?
I can.
I think that would help to see those subtle wrinkles.
Yeah, there you go.
Yeah.
So that's helped a bit, but it's made parts of the moon a little bit too bright now. Right, let's wander back down.
Another thing to see is that some of the craters have flat floors where they've been flooded with lava, like this one in
This
the
one
middle
here.
of the Imbrium. That's Archimedes. That's been completely flooded, so there are no small craters within it that we can see.
And this one here has got a little peak in the center.
We can estimate the ages of these features from how they overlie one another and which ones look fresh and undamaged and which have been damaged by later impacts.
Let me just look that one up and I'll tell you how wide that crater actually is to give you an idea of the sort of scale we're looking at.
I think it's about 60 kilometers, I would guess.
Right, Archimedes is 83 kilometers wide. So this crater here is 83 kilometers across.
Mhm.
Right, let's carry on down the Terminator because I need to switch over to someone quite soon. Back past the straight wall. But you can see just how varied the moon's surface is.
And the central peaks are due to the impact that created the crater when one of these meteorites slammed into the moon. It created this shock wave which spread out, and then in some cases the shock wave reflected back again and threw up material in the center.
And you can see that quite nicely in this crater here, which is Tycho. And you can see the central peak is just poking out into the sunlight. So it's high enough to poke into the sunlight before sunlight reaches the bottom of the crater. So that's quite nice. And if we wander down here, you've got this wonderful crater here, which is full of lots of little craters. So the impact occurred, then the lava flooded the plain to cause this flat area. And then we had lots of other impacts, created lots of craters inside that crater. So that's called
Clavius.
Clavius. I'm just trying to look it up on the map just to see how wide that is.
120 miles, I
Oh,
reckon.
there you go. Page 72. Here we go. So Clavius is 225 kilometers. So whatever that is in miles, yeah.
About 200 miles. So that's one of the largest craters on the moon, certainly one
So
of the largest
that's this one here.
on the near side.
Yeah, there are bigger ones on the other side, but we can't see them.
But there are no major seas. There are no Maria on the other side, apart from Mare Orientale, the famous multi-ringed basin. So the two sides of the moon, the Earth-facing side and the far side, are quite different in appearance. The Earth-facing side has these dark Maria all over it, which are the result of really big impacts, which cause lava to flood out over vast areas of the moon, and most of those correspond to single impacts which created vast impact basins surrounded by mountains, like the Mare Imbrium in the northern part of the moon. So clearly the moon has always been associated with the Earth, and its geological history has been greatly affected by the presence of the Earth. So presumably the crust was weakened on the near side of the moon by tidal forces, and that made it easier, I think, for the meteorites to puncture the surface.
Yeah, and just to go back to Tycho up here, it doesn't look very distinctive at the moment, so it's quite a relatively new feature. But if you go and look back at the moon when it's full, what you will notice is there's lots of bright streaks radiating out from that crater. And what's happened as the impacts occurred, it's blasted out all this material, which is much brighter than the rest of the moon's surface. It darkens over time. So the rest of the moon has darkened over time under the sunlight, but because that's only a few million years since that material has been splashed onto the surface, it hasn't had enough time to darken like the rest of it. So at full moon, these ray craters show up really nicely. And then the last thing I really wanted to show you was at the edge of the moon. We always think of the moon as being round or sphere, which it is. Yes, it is. But like the Earth, we've noticed that there's mountainous areas, there's flat areas. And if you look carefully at the limb of the moon, you can see that it's not regular. There are little peaks and lumps and little valleys in that curvature. And if you're lucky enough to go and see a total eclipse of the sun, this is what causes the diamond ring and little specks of light just as the sun's about to disappear or reappear, called Bailey's beads, as the moon covers up or just reveals the sun at the beginning and end of a total eclipse. And sometimes, if you're really lucky, you may get a star going behind the moon. And if it goes at an angle, you can see the star, especially if the moon's not illuminated by the sun, you can see the star flash on and off a few times as it passes through those little valleys on the edge of the moon. But they're quite rare occurrences, and you have to be in just the right place at the right time for it to do that. Okay, David, I'll hand back to you, and I think that's our tour of the moon.
Well, that's
go over to see in a little bit closer detail.
That's absolutely lovely, Dave. Thank you very much. And Dave will continue to be on hand, and I think he'll be able to show us some deep sky objects later because he's got a couple of different telescopes that he's controlling at once. We have an observer in Edinburgh. We've got Mark of the Edinburgh Astronomical Society, Mark Phillips. And I believe he has a 10-inch telescope. So that's a telescope about 4 times the size of the one that Dave was using. Dave was using a refracting telescope of 120 millimeters aperture. And Mark has a reflecting telescope, one which uses a big mirror to gather the light. And that's a 250 millimeter telescope. So, Mark, is it still clear in Edinburgh? And can you see the moon?
I can indeed. The seeing has just taken a turn for the worse as I've been watching it, as you might expect. But yes, so this I'll go through some of the features that Dave's just shown you.
At this image scale, you'll see the seeing much more because we've got bigger scale, bigger magnification.
That's right, yeah.
So you see, it may be that the seeing genuinely is worse in Edinburgh as well,
Yes.
because of more of a mountainous place. But yeah, with a larger scale from a bigger telescope, you see this seeing more.
Yeah, we are just magnifying it the same way. So the focal length of this is around about 2.5 meters now. We're looking at that. But you can see in more detail Clavius here, and these are often called the eyes of Clavius. You can see the 2 craters on the floor of Clavius. Earlier on when it started this, the floor was totally in shadow, but you can see it's actually starting to show up now as well. I always think that eye there has a bit of a teardrop just underneath it, so it's a sad crater, Clavius. But really good. If you remember, it was actually visited. It had a moon base on 2001: A Space Odyssey, I believe. So that's part of that. So let's go up the moon, and we'll head towards that crater there, which I think is Tycho, isn't it? Yes, that's the one that Dave also pointed out.
A very young crater. We think Tycho is the youngest of the major craters, probably less than 100 million years old. So Tycho formed when the dinosaurs were roaming the Earth, and they might have even, some of those dinosaurs may have seen the explosion, which was, if the moon was up at that time, it would have been quite spectacular, quite a spectacular flash when that meteorite hit the moon and created Tycho.
Yeah, that's right. And of course, that was in 2001: A Space Odyssey as well, where the TMA-1 was discovered as well. And I think you can probably see some of the really small craters on the moon at this scale. And the really small ones we're seeing here, they're sort of 2 or 3 kilometers, 1, 2, 3 kilometers across. So you can see quite a lot of detail, but that's about as small as I can go with this telescope. But it's a very innocuous crater, that one. I always find it rather interesting because it's very dramatic, other phases.
It's not quite at the south pole of the moon, but it looks as if it is at full moon because it has these rays emanating from it that look very like the lines of longitude on a globe of the Earth. So it looks like it marks a pole. And there's the straight wall again.
Here's a straight wall, also called Rupes Recta, I think it is. And so obviously The left-hand side has dropped and the right-hand side is higher because the sun is coming from the right here. This is close to lunar sunrise at this part of the moon. But that's always a favorite feature of amateurs to look at, and little mountain range at the bottom there. And this crater at the top right here with a nice central peak, I think that's Arzakon, is that correct? I think that is.
Yes, that's right.
And
It's
a bit of a fault there as well in the floor of the crater.
yes, Alphonsus and Ozarkol, that pair of craters.
Yeah.
Is that a black and white camera?
It's a color camera, but I'm using an infrared filter today, so it's only allowing infrared through. It actually helps with the poor seeing. And I was actually using it just before we started in the daytime when the sun was up, and I was getting really good images of the moon then as well. So it does actually allow you to do lunar imaging during the daytime. So it's a great little toy to have.
Yeah, so we're actually viewing the moon here in invisible light, which is close to the visible range, but it's picked up very efficiently by this camera. And in these longer wavelengths, you get less distortion due to the seeing.
But you can see that the seeing is coming and going. We've got patches which are not too bad at all, and then it can suddenly disappear altogether. But let's carry on up. Those are the nice three crater chains. Which way am I going? That way. And you can see some of these craters just starting to appear out of the in the lunar sunrise as well. So we head further up the moon. And where are we heading? Everything's back to front. And here we go. This is the Apennine mountain range with Eratosthenes on the left there.
It's not back to front. It actually is the right way. Your moon is the
No,
right
sorry, my controls are the wrong way up.
Yes, I see. Yes, that's Eratosthenes, that
Yeah.
crater in shadow there. And if it can we look just to the left of Eratosthenes, just below, no, the other way.
Yeah.
Yeah, and a little bit south. Yeah, there. You can hardly see it, but below left of Eratosthenes, there's a very faint crater. Maybe we can brighten that up a bit. That's what's known as a ghost crater. That's called Stadius, that ghost crater.
Yeah.
And it's all been almost entirely obliterated. It's a major crater, but later flows of lava associated with these maria. This is the Sinus Aestuum, this bit of maria near Eratosthenes. This flow of lava has flowed over the walls of Stadius and almost completely obliterated it, and also lots of later impacts have worn it down. So there's a ghost crater for you. It only shows up under a very low light. Here, you wouldn't see it at all in a couple of days' time when the light is higher. It's just got very low walls, which just cast the shadows when it's right on the terminator. But in general, the walls of craters are quite low compared to their width. They're like saucers. They're not like deep dishes.
Yeah. And here at the other end of the Apennine, you can see these rills, these channels here. This is around Hadley Rill, and I think, as Dave mentioned, this is where it was Apollo 15 landed there. Was that the place that they thought they discovered orange soil, I think? So you remember something about that?
That was Apollo 17, I
Was
think.
it 17, that one?
Yeah,
Right? Okay.
yeah, I think that was the orange soil, yes. So
Yeah.
there are different colors on the moon, although you can't see it very clearly generally, but different minerals on the moon give rise to slightly different color soils. You get more iron-rich areas, which are redder, and more aluminium-rich areas, which are bluer.
And this is Archimedes, I believe. That's quite a
Yeah,
nice, flat, smooth crater, that one.
yeah,
So
flooded crater,
yeah.
no craterlets on the floor.
All right. So we're heading up towards the Lunar Alps now that Dave showed us before. So here they are, and there's the Alpine Valley going through the mountains there. And probably if I manage to process this, there is actually a fault going down the middle of that valley, which is quite hard to see, but you can actually bring it out with a bit of processing as well.
Yeah, our understanding of the Alpine Valley has changed. People used to think that it was due to a meteorite which blasted through those mountains in a very diagonal, almost horizontal fashion. But the fact that there is this very fine valley, which can be seen under good conditions and can be imaged, as Mark said, this shows that it's a complicated feature, and it's actually a geological feature. It's actually a fault again. It's a rift valley, like the Rift Valley in Africa.
And here is the crater Plato, which is one of my favorites. If I increase the brightness here, you can see the shadows of the crater wall on the floor there standing out quite nicely.
Interesting to see if we can see any of the small craters in Plato. They're quite difficult to see, but with a big telescope, I think we would be able to.
I can actually capture them by processing it, but I've never managed to see it while it's live like this because it's just moving too much, really.
Yeah.
And there's a broken bit of crater wall here that's slightly fallen away, so you can actually get a bit of light on the far side of it. But yeah, and I think this is Mons Pico, little mountain, which has its own nice shadow there as well.
Isolated mountain. The lunar craters are, in general, they're named after scientists of the past. So Plato, ancient Greek philosopher, and you find a lot of the biggest, most prominent lunar craters are named after classical thinkers, philosophers, and writers, because they were named before a lot of modern developments. So Einstein, for example, only gets a tiny crater. Newton gets a tiny. No, Einstein's got a good one on the far side, come to think of it. But Newton's got a tiny crater on the near side of the moon because, well, it was about the same time as the guy who named most of the features on the moon. Is Riccioli and Hevelius named some, but I think they weren't great fans of Newton, so they didn't give him a big crater. They were big fans of Copernicus, and they gave him a good crater.
Yep.
And all these ancient thinkers like Plato and Ptolemy have good craters.
Yep. Okay, well, those are all the main features I think we covered. I can stop sharing that now.
Well, that's a splendid overview of this phase of the moon, and we'll see the subsequent phases in subsequent evenings, hopefully. Oh, this is interesting. My image of Jupiter has sort of emerged now, so I've got a bit more clear sky than I had, and I might actually be able to show that to you now. Let's get it a bit, try and get it a bit better focused. Let's yeah, I can share that with you now before it disappears. So this is my image of Jupiter through a 14-inch telescope and through clouds coming and going. And you can see it's got these parallel belts are the main features, the north equatorial belt and the south equatorial belt. This image is actually south at the top. Now, seeing is actually terrible, which is not surprising because the clouds are coming and going, and there's obviously lots of different temperatures of air. I've got a system where I can slew the telescope. I can move the telescope around from sitting in my warm room. I'm sitting in my warm room currently, just nearby the observatory, and I can also focus. So I'm trying to focus it a bit better by pressing a button. Let's see where the optimum focus is. It's difficult to judge because it's in such a state of movement. The optimum focus is around there. You can see there's these dark plumes here, dark plume on the north equatorial belt extending into the equatorial zone. The zones are the bright areas and the belts are the darker areas. And we're expecting the great red spot, which is not visible at the moment, to come round. That's not part of the south equatorial belt, so that would be somewhere up here if it appeared. In good conditions, we can see a lot of other small spots on Jupiter, but we can't see too much at the moment. So this is the view of Jupiter through a 14-inch Schmidt-Cassegrain telescope in London. And I will now leave that there. In fact, what I could show you next is a picture that I took and processed. So you can see the difference between that kind of raw image and one that's had its final processing. There's one which I took on the 22nd of January. I've inverted it now so that north is at the top and the Great Red Spot is in the south. So there's the Great Red Spot, looking quite small these days, not as big as it used to be, not as prominent, and smaller white spots. These spots move all the time. They rotate around the planet at different speeds, and we can measure the wind speeds in Jupiter from the rates at which these spots are going round. And there's a lot of amateur work done on monitoring the weather of Jupiter because there's no continuous professional monitoring of Jupiter's atmosphere. We do have a probe at the moment, the Juno probe, but that's examining the satellites, the moons of Jupiter as well as Jupiter. So it's not looking at the whole of Jupiter in one go as amateurs are. So amateurs across the world keep Jupiter under constant surveillance and monitor its weather and other events like the meteorites can strike Jupiter or comets can strike Jupiter as well and create effects. So next on the agenda, on my agenda, we have another astronomer, Trevor Pitt, who's located on the south coast in Chichester. And I think it's maybe cloudy for Trevor, but he's in his observatory, as we can see. So what's going on there, Trevor?
Well, it's very interesting. I'll just share my screen. There we go. Hopefully you can see that as you finished the last talk, it was completely cloudy, and then while you were talking, showing your pictures just then, suddenly there was a gap in the cloud, and there's the straight wall, which we've mentioned already tonight. But that's not what I'm going to talk about. We've had a good view of looking at some of the features on the moon. What I want to go into is just a little bit of a short talk on something called the Lunar 100. And the Lunar 100 came from an idea that was published in Sky and Telescope, an American magazine, way back in April 2004, so over 20 years ago. And what they decided to do was that because of the advent of these CCD cameras, we use CMOS now, but CCD in those days were quite small, and people were then starting to develop something called webcams, which you're seeing me on at the moment, and they were getting reasonably good views of the lunar surface. And so as an imaging challenge and also a visual challenge, the guys at Sky and Telescope, or the author, came up with 100 objects which were useful to see in sort of increasing order of difficulty from number 1, which is a picture of a full moon, all the way up to 100, which is quite a difficult object to see. And so I'll just go through what I do with my telescope that I've got at the moment, which is I mentioned it once before, but it's a Rishi Shretien with a ×2 Barlow, giving me a focal length of about 3.2 meters, and I was using a small planetary camera going over the surface of the moon. Now, my current camera will actually encompass the whole moon, but unfortunately, it can't do it very quickly when it's downloading the file. So that this concept of seeing that we were talking about earlier, where you can see the moon going in and out of focus very slightly, sometimes it's a lot worse than that. And we have the ability to capture a very fast frame rate video footage of the surface that you're looking at, and then extract the best ones from that and process them. And so that's essentially what I've done. I've gone through all 100 targets, and I'm just starting on the Lunar 200 targets as well. And here's just a list of them on a web page. That's the South Downs web page. And this is lunar target number 3. And what I've done here is I've tried to show the difference between the lighter areas, the higher albedo areas where the mountains are, and the much darker plains where the mare are, which is the lava flows. And I've also, in this particular one, I've tried to bring out a little bit of the color on the surface of the moon, which is dependent upon the types of minerals on the surface. And you can see here that this is slightly blue in color, and this one's slightly orange. So this one here is composed mainly of a titanium ore, and this one here is an iron ore, and very similar to what Mars has, of course, on the surface, but giving it that reddish hue. So although the moon is not quite so coloured as Mars is, but it certainly has evidence of iron on the surface. Moving on then, and I'll just show some pictures down the Terminator, which you've all seen tonight also. So this is Tycho crater. Again, about 1,000 images taken on this, and then you take the best 10% or 20%, and then you can because you've got such a good signal to noise ratio, you can sharpen them up and get rid of all of this movement that you see in the scene in the live image. And it produces a much, much better image than ever you could see by eye. And it always amazes me when I look at these images just how good they are in comparison with the view through my big Dobsonian telescope, or even the 8-inch when I'm using an eyepiece on it. There's Rupi's rector, the straight wall. And of course, the thing about this, which is also very interesting, when you're taking the Lunar 100, you could actually easily make it 200 by taking a picture, not at a waxing moon, but at a waning moon. And of course, the wall here would then appear light as opposed to in shadow as it is in this picture. And so you can take many, many different images of the same thing at different lunations, as they say, and get different effects. Moving up to Plato, there's Plato crater, which you saw in a little bit more shadow on the earlier images that we were looking at. And I've highlighted there where the craterlets are. And those craterlets are about 2 or maybe 3 kilometers across, so they're pretty small. People often say, well, with your big telescope, can you see can you see anything to do with the landings? And of course, I said, well, I can barely see 2-kilometer craters, so it's unlikely that I'm going to be able to see anything of the landing. But that can just about be seen in a good telescope, probably of the class of 12 to 14 inches. So maybe, David, you can see it in your 14-inch, the craterlets.
Yes, I can occasionally, but it does require good seeing. I'd like to compliment you on your annotation of your image. This is very important, that keeping full notes of exactly what you've done, exactly when it's taken, what date it's taken, and all the details. That's exemplary. So well done, Trevor.
Well, you wouldn't believe that probably took me 10 times as long to do compared with taking the pictures. It's a lot of effort, to be honest, to do those, but it's worth it because I forget what they are quite often. We've also seen Clavius, and there's Clavius. One of the nice things, I don't think has been mentioned tonight, at least I haven't heard about it, is that you can see here that the eyes, which was mentioned earlier, but as you look around here, there's a whole ring of smaller and smaller craters. And it's a bit of a challenge, depending on the size of your telescope, to see how many you can count in that ring. So that's sort of a bit of an observing challenge for you. Just a couple more. There's Patrick Moore, of course, in the earlier days, in the 60s, he believed that the craters were formed by volcanism. But of course that was disproved, and he accepted that as an error on his part. But there are volcanoes on the moon, and this is a dome feature, dome case pi. I hope you can see that just about in the center there. Very tiny little dome with a very small 1.5 kilometer caldera on the top of it.
Also of interest in that picture are those parallel rings which are surrounding the Mare Humorum.
This one here?
Yes, those cracks, those parallel circular cracks are really quite striking. And show you how the crust has faulted in response to that big impact. That I think that's the one that produced the I think it was the Marihuma and one of the big circular basins.
Yes, yes. I mean, it is quite interesting when you look at this crater here. I'm not sure what it's called, but you can see definitely where one of those the faults are. That this side of the crater completely different to this side of the crater. So whether this was filled up and the defect there stopped the lava flow going into the other side, I don't know. I have to look into that a little bit more detail.
Some of these features obviously have very complicated history and takes a lot of detective work to piece them together.
Just a couple more. I think you mentioned a bit earlier about a ghost crater, but there's another very difficult one to see. I had probably about 3 or 4 attempts at this, and that's a monthly attempts because there's only a few hours when you can actually see this thing. So if you miss it or it's cloudy or whatever, you just don't get it. But eventually you get it. So although you can see everything at the moment on the moon, these images do take a long time to gather, several years, in fact.
Well, that's a lovely collection, Trevor.
Okay. So
Thanks. Oh, yeah, and you've got a nice one of
Oceanus Pressure
that's
Lava.
the Hyginus real the Schroter Valley there, and
Yeah.
Aristarchus, and what's the other one? The dark one next to it. Yeah,
So
and
this one here.
yes, that's Schroter, isn't it?
Yeah.
And this is the
Yeah, that's Schroter. This is the rill coming from it as well.
yes, that
The
U-shaped
snake and the head of the snake, I think.
snaky shaped valley. And
Yeah.
Aristarchus is one of the brightest points on the moon. So it's a very young crater. And you can see clearly there how it's bluish. It's one of the most aluminium rich, bluest bits of the moon.
Yeah, it is. It's brilliant. So I think that just about completes my presentation.
Right. Well, I'd like to move back to Edinburgh now because I asked Mark in Edinburgh if he would be able to look at Jupiter at this stage. So have you managed to track down Jupiter, Mark?
I have, yes. The seeing is still coming in and out, but it has moments of steadiness where you can make things out on it. There we go. So that is back to just ordinary color. I can flip to infrared shortly to see the difference. And you probably can't quite see it, but the great red spot is just starting to come onto the visible surface of Jupiter just around there.
Oh, it's well spotted. It's hard to see.
Yeah, I just checked on WinDuPos as well, which says it is just about there.
We've got Jupiter has this strong limb darkening that the limb tails off in brightness, and that's showing us that it's not a solid surface. Objects which have a solid surface like the moon remain absolutely bright to the edge, whereas the gas giants like Jupiter get darker towards the edge, and the sun does the same thing because you're looking through a thick layer of atmosphere in Jupiter before you get to the reflective layers. So you get this trailing off of the light towards the edge of Jupiter. But the great red spot is coming on, and it rapidly comes on because Jupiter rotates once in 9 hours. So in only about 3 hours, it'll be bang in the center.
I can flip to an infrared filter to see the difference.
Mm.
There, and there we go. So normally, and the great red spot will stand out much sharper. Infrared is a bright white spot, and any storms that we might have, such as we've had in the NTB, the North Territorial Belt, have been standing out really quite bright white in this as well. I do have a methane filter on here, but I suspect it's not going to show anything up very much. But I will flick to it just in case. Yeah, it's probably on the edge for my telescope, so you can't really see it. If the great red spot was around, that would also be showing up quite brightly as well. But one thing I do notice is Jupiter is much rounder when you look at it through methane. It doesn't have quite the same falling off at the edges as it would otherwise. Yeah.
Mm. Yeah, the methane light captures the high features in the atmosphere, and the great red spot looks bright in methane, and the equatorial regions look bright, and the polar regions much darker.
But you
And
can't really see much live. You need to process that.
And the moons look bright in methane light as well, which we haven't seen any moons today because the field of view of the telescopes that we're using is too tight to get the moons in. But it's worth mentioning the 4 Galilean moons of Jupiter, 4 bright moons, which you can see even in a good pair of binoculars and certainly in any small telescope. And we're just looking at a wider view now, see if we can see any
I'm
moons.
just going to see if I can see any. Wrong way. Turn that
And
off.
they're normally roughly in line with the belts. They're rotating in the plane of Jupiter's rotation.
Yeah, I think if I'm going to do that, I'm going to lose it.
Mm.
Oh, there they are.
Yeah, there's a couple.
Yeah.
Those little star-like points. Those are actually substantial worlds. They are similar size to the Earth's moon, or a bit bigger.
So
Ganymede is the, in fact,
those are Europa to the left and Io to the right.
yes, Io is a very volcanic object, the most volcanic object in the solar system. And the Juno probe has been monitoring Io and showing that the surface of Io has changed since Jupiter was visited by the Voyager probes in the last century. Volcanic resurfacing has occurred on Io. Yeah, we can see the colours of the belts and zones very nicely there, and these dark grey projections into the equatorial zone. There's quite a lot of activity on Jupiter, but it's not the best seeing night, so we can't see the finer spots. There has been an outbreak of activity in the North Equatorial Belt recently, and a lot of fine spots and turbulence.
Yeah.
Well, we have another astronomer who we haven't spoken to yet, Martin Bracken in Chelmsford. Thank you very much, Mark. Martin Bracken in Chelmsford. So I'd like to see if Martin is on the line and what conditions he is experiencing.
Hi, David. Yes, I'm coming in and out with the moon and Jupiter. I'll just see if I can show you Jupiter at the moment. Let me just share this screen if I could do that. Share. There we go. Yep. So this is just with a 6-inch SCT, which is a reflecting telescope, and it's got a 2 times Barlow lens on it. But you can see some of the belt data there, and also some of the zones, and you can see some of the dark areas from the belts going into the zones. You still can't quite make out the red spot. It may get a little bit better if I stack it. Let me just see if I can do that. What this software is doing is actually live stacking the images as they're coming in and placing them on top of each other. The color looks a bit off, but let's just see what we can do about that. Take it down a bit. And you can see the sort of blue hue, which is actually due to the atmospheric dispersion. That's the light coming through the atmosphere and being dispersed at different angles. So you can get a piece of equipment called an atmospheric dispersion corrector, which actually deals with all of that. But unfortunately, I haven't got one.
So this is actually a live view, but
this is a live view.
It's a slightly delayed live view.
Yeah, well, it's actually stacking one picture every 24 milliseconds. So, and it's so far stacked about 90 pictures. So this is only a second or 2 seconds behind what you're actually seeing. But by doing that, you can actually bring out a little bit more detail. I'm just trying to see if we can get the great red spot, but I don't think we can. It could be there. But that wasn't really what I was planning on talking about. Just so happened I actually get Jupiter in the field of view. I was going to say something a little bit about clusters, because I understand that was our theme for the day, about star clusters.
Well, I can only give you a few minutes because we've got Dave Eagle has still got a telescope which can actually view some open clusters. So
In which case, I think you should go to Dave and then perhaps come back to me if you've got time.
Righto. Let's leave Martin and go back to Dave Eagle, who has a telescope, I believe, trained on the Messier 35 cluster. Is that correct?
I am, yeah. Let's just let you have a look what's coming down through the camera. So this is coming down through the camera as we speak. So it's taking a 30-second exposure, one after the other, and it's live stacking them together, because the more images you stack together, the better the image becomes.
That looks very good. Are you in quite a dark site, Dave?
Not particularly, no. I'm a little bit better than I was. I'm in a small town in Northamptonshire. There's quite a few warehouses around me which have got quite glaring lights around them. But you can see the cluster quite nicely. This is what we call an open cluster. There's lots of space between the stars.
I think we've got two clusters for the price of one.
Yeah, I was going to come to that in a minute.
Yes.
So you've got the lovely open cluster there, you can see quite nicely. And this is in the foot of Gemini, so it's in Gemini the Twins. And then just down here, you can also see another cluster here. Now that is about the same size as the cluster we're looking at there, but it's about double the distance. And so if we get the software to tell us the objects that are in there, you can see it's highlighted Messier 35. Now the catalogue Messier was put together originally by Charles Messier, who was a comet hunter. And when he came across fuzzy objects in the sky that didn't move, he put them down in his book. Don't bother looking at this because it's not a comet, because we love these objects these days. And the Messier catalogue is a great starting point for you to go out and look at some of these wonderful objects in the night sky. And there are 110 objects in that catalogue. But the other cluster isn't a Messier object. It's what we call an NGC object, and it's NGC 2158. This is the new general catalogue of objects in the sky, and you can see that there. But we've also got an added bonus. If you look carefully down to the bottom right-hand side, there's also a very small cluster IC 2157, which is a very small cluster, so nowhere near like the other two. Now, if you remember, the other night I was on a couple of clusters, and I'll show you the pictures that I quickly captured from them. This is Messier 37, so that's another lovely open cluster. This is NGC 869, which is one of the two clusters in the sword handle, the double cluster. But Messier 37, if you take lots and lots of images, which is what I was hoping to do, but a little while ago, my skies clouded over, so I couldn't show you the image that I'd captured. When you capture lots of images and add them together, you manage to capture an image that looks like this. This is Messier 35 again, and NGC 2158 here, and you can see that cluster in much more detail because you've captured much more data. And you see nice colours in the stars as well. And the smaller cluster looks a little bit sort of brownish, and that's because there's lots of Milky Way dust and gas in between it and us, making it just that little bit browner. Okay, David.
Right, so the sky really is full of clusters. All these clusters are galactic. They're quite nearby. They're quite nearby neighbours on the stellar scale, but there are other clusters, much more distant ones, which are much bigger, more concentrated. They're known as globular clusters, and they exist on almost a galactic scale. So Martin has a word to say about globular clusters. So tell us a little bit more about them. Would you like to? Haven't got very long, but
No,
say a bit more
I'll
about
be as
them.
quick as I can, David. Let me just see if I can share this. Let's just get onto that. Sharing the screen seems a bit difficult at the moment. Doesn't seem to want to let me. Here we go. So here, can you see that? This is the
Yes.
M3 globular cluster. It's part of the Messier catalogue that Dave was talking about. In fact, when this is the first object that Messier himself catalogued, and this is a globular cluster with about 500,000 stars in it. That they are all held together due to their gravity. They're very, very close. Sometimes they collide and form new stars. In fact, when Messier first discovered it in 1764, he thought it was a nebula because he couldn't resolve any of the stars. And it took William Herschel, I think, to actually resolve the stars and then classify it as a globular cluster. But you can see that it's a very, very densely packed bunch of stars. And if you do what Dave did, which was also put the annotation on it, what I've highlighted here is the number of galaxies that are actually in that image. If you look at these, this is from the principal galaxies cluster. All of those PGC little blobs are in fact galaxies and not stars. It's quite amazing, the detail and the just over population of galaxies that you can see in just any one image. But moving on, this is M13, which is probably the most famous globular cluster because it's in the Hercules cluster. Once again, this is a densely 100,000 stars in the M13, and Edmund Halley discovered this, I believe, in 1714. And Messier added it to his catalogue around about 1764. So this once again is another amazing sight and you can see this with the naked eye. Well, you can certainly see it with small binoculars, but you can also probably make it out just about with the naked eye.
Visible in the summer sky.
Yes, only in the summer sky. And the last one, which was an open cluster, which is the one which I was hoping to show you live tonight, but I couldn't, which is the Pleiades, which is M45. And this is very much the Seven Sisters. When you look at it with the naked eye, you can just about resolve 7 of the stars, but you can see there's quite a bit of nebulosity. This is mainly reflection nebula around it. But you can see that you can only resolve about 7 stars with the naked eye. But once you actually look at it, it contains considerably more than 7 stars.
Tomorrow, I think the moon will be quite close to the Pleiades, and we'll probably be talking about it more tomorrow.
Okay.
So,
thank you, David.
Thanks very much, Martin. One thing we haven't talked about actually is the red planet Mars. So I'll just quickly show you the image that I took last night of Mars. This was taken at about 11 p.m. last night. And this would be the view of Mars roughly that we would get now as well. This is the North Polar Cap, this light area. And this is the Solis Lacus, this dark feature, also known as the black eye of Mars with this dark surround. Valles Marineris is in this area just north of Solis Lacus. And you've got some of the volcanoes here. This is the Olympus Mons, the highest mountain in the solar system, is just there. And we can just make out these lighter patches are some of the other volcanoes on Mars, the Tarsus volcanoes. So Mars is rapidly moving away from us. We've only got a few more weeks to observe Mars, but you can see some of these features in modest-sized telescopes. This was taken with a big telescope, a 14-inch telescope, but you can see certainly the polar caps in a telescope as small as 3 or 4 inches aperture. So do take a look at Mars if you can, and we'll probably have some live views of Mars, hopefully, in the next couple of days. So it's time to wrap up this broadcast of National Astronomy Week. It's been a great pleasure talking to you. I'd like to thank the astronomers on the call, Martin Bracken, Trevor Pitt, Mark Phillips, Dave Eagle, And yes, that's all. I think for their splendid contributions and for braving the cold in their various observatories to show us the wonders of the night sky. So it's good night from me, and thank you very much for watching.